Hi guys, so this is lesson 88 and today we're going to talk about symmetry. Symmetry is really cool, not only because it's like cool, it's a math thing, but it also occurs in nature and science and so many different things. And so we're going to talk about that a little bit here. Your lesson part isn't super hard. All you're really doing is looking at shapes and being like, is this symmetrical or not? So I hope that this will be kind of a nice break from the rest of math for a little bit. A polygon has symmetry when one half of the polygon is congruent to the other half. A line can divide a polygon into two congruent parts that are either mirror images or matched by being rotated or flipped. So in your lesson on the page, it gives you an example with a polygon that's a rhombus. A polygon may have 0, 1, or more than one line that forms the congruent halves. So here's your example here. This is just the regular rhombus, but you can look and see these are probably the two first easiest ones to understand. If you fold this shape in half, it's going to be the exact same mirror shape of the other half. Or if you fold the shape the longwise, this is called a vertical symmetry and this is horizontal symmetry because the lines you fold on are either vertical or horizontal. These two are a little bit different because if you take a piece of paper, which I could just use this one, if I take a piece of paper and fold it corner to corner, that's a rectangle, it's not symmetrical. See, they don't match up. They're not the same. Whereas if I folded it in half, it's the same, right? I have the exact same shape and size of both halves of the paper, but I can't do that diagonally. I can't do that like this. But I can if I flip it. So here's my note card, and I'm going to draw the not draw the diagonal line, but I'm going to cut it diagonally across, and then I have two halves that actually are symmetrical. See, they're congruent, they're the same. Well, mine aren't quite because they're not perfect, but so if you take your halves and you flip it, you can have a type of symmetry too. If you have a triangle like this, you can fold it and usually horizontally and it will be symmetrical as well. And so those are just different ways kind of in geometry that you're going to use those. Next, I'm going to show you some examples in architecture. Okay, so here is some examples in architecture. This picture right here, see my following, is the Taj Mahal. It's a famous building in India, right? So see how it's symmetrical on both sides. One side mirrors the other side, and you can even see that in the reflection, how if you had one half of your building, it would mirror it in the other half. Here's another example of symmetry in architecture. If you flipped this side to this side, they would match completely. Here's another more complex one of the Sydney Opera House, I think. And so it mirrors the same side. It has exactly the same sides. I was gonna try and find, here's some other ones you can kind of see symmetry. I'm gonna show you some flowers, just a second though. I have to find my Okay, so here are some symmetry. Here are some examples of symmetry in nature. Here's a flower. See, if you cut the flower in half, it's got the same on both sides. Any of these really. This one even, this one. So symmetry is also just a balance of things. So when you have one side and one on the other side. Another kind of cool thing to think about is symmetry in humans. If you take your face and draw a line right down the middle, you have symmetry, hopefully. But you can't do it horizontally because that's not the same. But if I drew a line down my face, I would have the same on one side as it would on the other. It mirrors it. So that's symmetry in a nutshell. And now we're going to look through the rest of the lesson. Okay, so back to our paper. They gave you a pentagon. you need to figure out how many ways of symmetry you can fold that or make that. So you're just going to be using lines, you're not going to be folding it, but imagine if you had a paper one, you could just fold it in half. So the most obvious way is probably obviously just a line right down the middle, because if I drew a line right down the middle and folded it across, it was going to be the same. However, there's actually 4 other ways you can do it. We talked a little bit about rotational symmetry. If I were to turn my paper and now my shape is the same as it was this way. So because of that, I can also fold this shape again right down here. And if I were to turn it, I could fold it again and again and again, okay? So there's basically, you're just gonna draw a line down the middle. You're gonna draw a line dividing this side. You're gonna draw a line from this point dividing this side, and then from this point dividing this side, and this point dividing this side. So that's all you're doing for that. The next part. I can't write this backwards. For each of the digits 1 through 9, draw the lines that divide the numbers into congruent halves, if any. So congruent means, if you remember, same shape, same size. So what I just did was just drew all the numbers right here, 1 through 9, and then you're gonna look at them and see if any of them can be divided in half to the same shape and same size. It's not as hard as it probably sounds. So we'll make it really big here. I have the number 1. Can I make the number 1 symmetry? If you have a 1 that's like this, no. I cannot draw a line down the middle or this way and get this same shape. If I have a line like this, technically you could, because if I fold my line in half, it's just half the line, right? Or if I fold it this way. So if that one you want to count, you don't have to if you want to. 2. If I draw a line down the middle and a 2, it's not symmetrical. If I draw a line down the middle horizontally, it's also not symmetrical, right? 3. Okay, 3 is a little bit tricky, because if you have a 3 like this, then no, you cannot fold it and get the same C. But if you have a same size, then it is, right? So you could do it symmetrically this way, not this way. Okay. 4. Yes or no? 5. Yes or no? 6. Those are all no's if you're waiting for me to answer for you. You can't divide those evenly. Go ahead. You have 7, 8, and 9. You can do those on your own. One of them is, and 2 of them aren't, if that helps you. Okay, so quick review part on section 3 and 4. Sorry, we'll do that in a second. Section 3, you're doing the exact same thing you did with the numbers, except you're going through the alphabet. So A, and they have it written out for you. So just write how many times you can make that letter symmetrical. So like an A, you can fold in half and it can be symmetrical, right? Here, I'll show you. So A, you can draw it down the middle, and you're gonna have the same thing if you were to fold it in half. But it would not be this way. If I folded it top to bottom, it's not symmetrical. So then you would just write 1 in the box, because there's only one way to make it symmetrical, okay? So there's that. Then for part 4, you're gonna do the interest rate. Remember, it's basically your answer equals principal times 1 plus R, or the rate, and then to the time, okay? So the first one, you're gonna set up like this. A equals 1,500 times my rate. Remember, I think we missed this a couple times in the other one that we did. I'm gonna do 1 plus, you have to move your decimal point. So it's gonna be 0.009. Do that first, and then your time to the third. You can use your calculators on that because you need to. Don't forget your XY button on the calculator. That's the one that does it. So hopefully you kind of remember how to do that. We didn't do that too long ago. Okay, we're gonna now go ahead and look at this trapezoid problem. There's a few steps that we're just gonna do together today. I don't have to explain that. Okay, so your problem says Mike is installing a sandbox on the side of a play area. The diagram at the left is a scale drawing of the sandbox with a ratio of 2:5 and all measurements given in meters. So what is the area of the sandbox in yards is what they want the answer to. So you're going to convert the measurements first to yards and round your answer to the nearest hundredth. Okay, the one part that is kind of confusing that they don't really state specifically is in the first part that this is a scale drawing. So if my 2 is representative of a 5, I have to figure out that for each side, okay? Ultimately, I'm looking for the area of a trapezoid. So my formula for the trapezoid is 1/2 of my base 1 plus my base 2 times my height. But I forgot to write the height. The height here is 2 as well. So I know that I need this number, and this number. So because I only need those 3 numbers, I don't need to figure out these sides at this point, okay? So I have to make my scale to the actual size first. So my ratio was 2:5. So that's actually really easy because if 2 equals 5, then all of my 2's equal 5. So this is really 5 meters. My height is 5 meters. And then this little piece right here is 5 meters, okay? Yeah. But now I have to figure out how long this actually is in meters, okay? So what I'm gonna do is take my 2:5, my key, and then make a proportion. So if 2:5, 2 equals 5, then what equals 6? Oops, I did that backwards. And then 6 equals what? Okay, that's what you don't know. So you're gonna cross multiply. You're gonna go 2x equals 30. Get rid of my 2. 2 into 30 is 15. So this is actually 15 meters, okay? All right, so now you know what the actual meters are. Now you have to convert it to yards. So 1 meter is 1.09 yards. So all you have to do is, you can even add these at this point. Go 20 meters times 1.05 and 5 meters times 1.09, sorry. And that'll get your yards. So you can use your calculator on that. I did part of this, oops. 5.5 meters is 5.45 yards. And then 20 times 1.09, whoops. Is 21.8 yards, okay? So now I've converted my meters to yards. Now I can finish my problem, all right? So again, 1/2 of my base plus my base 1 plus base 2, which is the top and the bottom, times my height. I use a different color so that we can see. So what you're gonna do is 1/2 times B1, we're gonna say, was 5.5 yards, or 45 yards, plus 21.8 yards times my height, which was also 5 meters. So it's going to be the same as 5.45 yards. And so you're going to add this, multiply it by this, divided by 2. All right, so I'm going to see what you get there. And that's okay. And the last part, I'll just kind of talk you through too again. We won't actually do it together, but so if 150-pound bag of play stand will cover 1 square foot, what is the minimum number of bags Mike will need to cover the sandbox? So you have 1 square yards equals 9 square feet. So how many bags will cover 1 square yard. You have 3 feet in a yard, so you have to figure that out. And then you're gonna take your answer for this and multiply it times your answer for that, for how many feet are in a square yard. And then round up your bags to the nearest bag, whole bag, because you won't use a, he'll need, if he is going to use part of a bag, he'll have to buy the whole bag, right? So don't forget to do that. Okay, have fun.